we're going to do is look at things outside the function. And so far outside the function, we've added and subtracted, moved things up and down. We're going to start noticing a pattern that everything that's outside the function affects the graph vertically. The same thing happens here. If we have a negative outside the function, it would take whatever graph you had and flip it vertically over the x-axis. So I pretended here, if I had a point, and that point happened to be 8, 4, if you flipped it, all that would happen is your y value would get multiplied by a -1. So on the space beside this chart, we're going to write about this much stuff. Here's half of it. First of all, we're going to look at if the negative is outside the function, which means it's either outside the function or the negative is with the y. Then it is a vertical reflection. You're going to reflect over the x-axis. Algebraically, this means that your y values, just like that point there, notice the y value of 4, it got multiplied by a -1. So we saw this kind of in regular parabolas where your x squared parabola opened up and your negative x squared parabola opened down. But in parabolas, we never put a negative inside. Because if you put a negative inside a parabola, it actually doesn't do anything, because when it's squared, the negative would just go away anyways. But if you had just a random graph and you put the negative inside, it would reflect it over the y-axis. And if I labeled a corresponding point to the one I had to begin with, this means your x value will get multiplied by a -1. So if we scroll down, we can write that as well. So again, anything inside the function will be horizontal. And this would be a horizontal reflection. Algebraically, we would multiply the x coordinate by a -1. What this means. So here's the graph of g of x. We want to sketch the image graph after a reflection in the y-axis and state domain and range for each function. So first thing we're going to do in this question, I'm going to underline a reflection in the y-axis. With reflections in particular, there is a number of ways that a question can ask the same thing. So instead of taking 5 questions to see all those number of ways, I underline that part and I'm going to show you the different ways the question could ask the same thing. First of all, I always find it helpful to find out, is this horizontal or vertical first? So if I'm reflecting in the y-axis, that's moving things left and right over top of the y-axis. This is another way of saying it's a horizontal reflection. If it's a horizontal reflection, that also means the negative, they could also tell you to graph this, and the negative would be in the inside. The equation of the y-axis is x equals 0, because you're flipping over this line, you're reflecting over that line, and every single point you put on that line has an x coordinate of 0. That's why we label that line x equals 0. So I could ask you, or the test or the exam could ask you to reflect in the y-axis in any one of these ways. They could say, sketch the image graph of y equals g of negative x. They could say, sketch the image graph after a horizontal reflection. Sketch the image graph after reflection over the line x equals 0. Okay. It's affecting the x value, so maybe I put up in here, we're going to multiply all of our x values by a negative 1. What does that mean? Well, that means this point right here, which is 3 away, would get flipped over and be 3 away on the other side. This point at the bottom here is 1 away from the y-axis. It's going to be 1 away on the other side. This point is 3 away from your y-axis, so when I flip it over, it will be 3 away on the other side. And finally, the last point, 1, 2, 3, 4, 5 away, and 5 away on the other side. So when I draw this graph, I'll highlight the y-axis in green here. Can you see that the red graph has just been flipped over that green line to become the blue graph? Question says to state the domain and range of each function. I'll just choose one notation. So if we're doing the domain, those are our x values. Starting with the red one, my smallest x value is -3. My biggest x value is +5. And for my range, my smallest y value, -2, and my biggest y value is +2. For the blue graph, now my smallest x value, -5, and biggest x value, +3. And range, smallest y value is -2, and biggest y value is +2. Now, some things to notice. First of all, you see that the range did not change. The y values are exactly the same in the red one than they are in the blue one, which makes sense because the only thing that they said to change was a horizontal. And if horizontal only affects x values, it makes sense that your y values didn't change. Second, in the domain, could you figure out the blue domain if I gave you the red domain but no graph? Okay? Because sometimes on the exam they'll do this. They'll say, okay, how well do you understand things? What if we just give you a little bit of information and you have to find the rest? Lots of times we start with the graph, we flip the graph, then we looked at the graph to do our domain and range. Perfectly fine. But can you see that the domain, if we're multiplying the x values by -1, the -3 becomes a +3. And the +5, when multiplied by -1, becomes a -5. So we can see a pattern in the domain as well. All right, questions for practice on this one are 3 and 13.